Swayam Prabha. Digital India. Educated India.
Talk about the inspiration that we get from the inventions. Because supposing you talk about von Neumann, or it could be Newton, it could be, tell me other names that comes to your mind. Einstein, Sivakumar, correct? Yeah. What comes to your mind is, I also want to be that way, correct? Right? So that's an inspiration. So I just want to get you to be inspired by what we do today. Okay? Again, it's going to be a play mode. All right? Are you ready?
Yes, sir.
Quickly, I'm going to start on this. Yeah, let me take out this most important thing. And another important thing. Initially, I wanted to give you a choice, but time is short, so no choice. What I want you to do is, I'll pass this on to, so each one of you take one strip and pass on to the backbenchers, okay? Yeah? All right. Go ahead. We'll quickly do this. Backbench people can, if there is something remaining, you push it back to the front. Don't do anything with that right now.
So
Quick.
So one per group or one per person?
One per person. One per person. All of you should be participating. You have extra? Yeah.
They'll ask us to balance it. Hey, remember that come on.
Extra? Okay. Quickly, folks. Chocolate question. Right now, what you have is a strip of paper. I'm not going to ask you to do Mobius strip, but I'm going to ask you to make this strip a ruler. Okay, the name of this game is when two slightly different rulers fight among themselves. Okay, that's the name. All right? They fight among themselves. Now, how do you make a ruler out of the strip that I have given you? Wait.
Fold it.
Huh?
We can fold it.
Yeah, okay. Here. Okay. Yeah. Yeah. Okay, go ahead, fold. How many folds are you going to make? 100 folds.
Depends on how much we define our unit.
Go ahead, do it. And tell me how many folds you made. What are you making? You are making a ruler.
So they should just be equal intervals, right?
Of course, a ruler has equal intervals. Equal divisions. Done?
I didn't exactly get a centimeter.
How many folds did you make? How many folds did you make? 3, 4, 5. Okay, 5 is one of them. 5. Supposing I tell you that this strip length is 32 centimeters. You will be able to make a ruler of 1 centimeter division, right? Now mark them. As you mark them, I'll switch to my presentation now. Go ahead, mark. Done? How many folds? How many? 5 folds. Okay, 5 folds. Anybody did 6 folds? 6 folds. Okay. How many divisions then? How many divisions? Huh? How many divisions did you get? 60? 64. Okay. So make a ruler out of it. Fast. Let's get to the next one. Done?
So do you want to take a pen and mark?
Yeah, mark. Take out your pen, mark, so that it becomes a ruler, not a strip of paper. Not a strip of paper. She's trying her best to make it 128. Somebody is trying to make it 128 unsuccessfully. Where is your marking? Done, huh? Wow. Okay, marking done? Marking done? Okay, so what I want you to do is, those who have already marked, made a ruler out of the strip, mark 2 points on the bench. Shamelessly, mark 2 points on the bench, roughly about 10 centimeters in the distance, in terms of the distance. Done? Don't make the point very big. Done? Come again? No. Just arbitrarily, don't use ruler. Arbitrarily mark 2 points. It could be either on your notebook or outside, on the table, whatever. Mark 2 points. And you already have a ruler, there are 2 points. What will you do? Measure. Measure and tell me what's the length of, what's the distance between the 2 points? Yeah, okay. Go ahead, I'm listening. Huh? 30, 13, 10, 11, 9, 15. Go ahead. 9. Yeah. 8, 15. One more. 6. Okay. What are these numbers? In terms of centimeters, correct? Yeah? And how about the 64 ruler person? He's still marking. He gave up on it. Okay. Now, Is it 13.5 or 13.2 or 13.1? What is it? We don't know, right? But I want more accurate. You can't give me just 13 and stop there. I need a good ruler. What will you do? I don't know. Do it. Do it and tell me. Do it. Do it and tell me how you did it. But I'm a counter. Have you done it? How did you get 9.6?
I marked 1 centimeter, sir. And intuitively, I just equally spaced.
Intuitively, see, distance between this point and this point is, I'll intuitively say 100 centimeters.
No, sir.
Will you agree with me?
No, but you can intuitively mark 10 points.
Yeah, intuitively I'll mark like this.
Sir, your intuition is not good, sir.
Yeah, wonderful point. And I'm going to just put a mirror and then tell you this. That's all. Tell me, some more accurate.
Sir, we can, if we manage to mark 1 full centimeter with millimeter reading, then we can calculate the any length to precise to the millimeter.
Okay,
But the thing is, I don't know.
fine.
So, but we already like mark the length part. Take the breadth part. It's approximately 3 centimeters. If you take.
No approximation, no. The ruler is such that you want good measurement.
These points are equally spaced, so you can find one middle point in between each of these points.
How do you find the middle point? Try it.
So 10.9.
Huh?
10.9.
10 point? How did you get 9?
What I did is, I took the part between 10 and 11, I folded that part alone, like
When you fold it, what will you get?
a midpoint.
Center of that, which is
10.5.
10.5. Fold it again.
So 10.25, 10.75.
Yeah, tell me exactly what you got.
By folding it enough number.
But the point that I have marked is not coinciding. No. What will I do? Correct. But I'm not able to fold it that way. Correct? Yeah. 11.25. 11.25. But the distance between the 2 points, is it 11.25 or is it 11.21? How do you know?
So 10.87.
10.875 or 10.87 or 10.879?
875.
How do you know?
You get
10.5
8.5
to 11, I folded it again, which is 10.
So, what we understand is by doing this, we created a ruler. Even the ruler that we bought has a limitation. You all agree with me? Yeah? Is this clear? So, that's one thing that we came up with. Accurately measuring seems to be tough. Let's go to another scenario. It's like in a movie, director goes from one scene to completely a different scene. The different scene here is about a mathematician who proposed a lemma on co-primes. What is co-prime? Two numbers that have a
common factor of 1.
okay. Now, what he did was, he said, if you pick these two numbers anywhere on the whole number line, you will get it as co-prime. You will get the pair as co-prime. What are those two numbers? What are those two numbers? What are those two numbers? What he proposed was, anybody? Chocolate question. Huh? Consecutive. Two consecutive numbers. Any two consecutive numbers you choose, they will be co-prime. Yeah? Hey, what is this? Arbitrarily saying something? What is this arbitrarily saying something? You asked me to measure, I measured. You arbitrarily asked something, I am now answering. The two are not connected at all, correct? Yeah? It was a French mathematician in the 16th and 17th century. Okay? We'll come back to who it is. We'll continue with the activity. Do you have another step? Okay. So I'm going to give you another step. Yeah? Quickly pass it on. Yeah. Quickly pass it on. We'll finish in no time. Yeah. Now you're getting one more strip, right? One more strip. By the way, why are we interested in co-prime? Any reason? Apart from mathematical interest, is there any?
Graduate another scale with that number. Compare the two scales.
Which number?
The co-prime.
Co-prime number. So consecutive means 33.
Not like that.
You're quite close.
So like how to say 1 and 0.9.
1 and 0.9.
10 and 9. If you graduate them,
You can take the difference and put them everywhere. Then
Wonderful. You're getting there, but not yet. So still, I'll give you a nice. What is vernier cap? I don't know. Okay.
the French mathematics is very
Very good, yeah. So, shall we create a vernier caliper here? Yeah? We're going to create a vernier caliper. So I'm going to tell you how to do it. Yeah? The matter does not end there. So let's. What happened? Vernier caliper he already has. Okay. We're going to create a vernier caliper. How are we going to create? Right? What he mentioned was if we use 32, we use either 33 or 31. What shall we do? We already have a ruler which is 32 centimeters. What shall we do? 31. And what do I do with that 31? Wonderful. So what you do is, using the first ruler, take the other strip, fold at 31. Fold at 31. For example, if I found that this is the ruler that I already marked, listen to me carefully. I first make sure one end matches nicely and go to this end. Okay, this is 31, so I'm going to now fold it nicely and crease it. Yeah? Is this clear? You have a strip? Now, why am I creasing it? Huh? And then for what will happen? Okay, very good. So we can tear it very easily. Okay, so we are tearing it very easily. So we got a strip which is of 31 centimeters. What shall I do with this 31 centimeters? What shall I do with this 31 centimeters? Fold again, like what you did earlier, and make a ruler out of it. Nice, no? Fold again and make a ruler out of it. Yeah, 1 centimeter of the strip. The two strips are of same length, no? Now, I want to make it 31 centimeters, but I already have a ruler which is 32 centimeter ruler. I can use that and remove 1 centimeter part of the second strip. After that, I will do the folding.
So
Yeah,
you have to
quickly do that. Yeah,
fold it again in half.
yeah, of course. Because you are now making a different ruler. But this ruler is only 31 centimeters. And how many divisions? 32 divisions. Correct? It's not 31 divisions. It is 32 divisions. Done? Now what you do is pull out your notebook. Pull out your notebook. And now tell me, before that, once you have made this ruler and marked it, which are the 2 points where the markings coincide?
0.
0 and? Wonderful. Not anywhere else, no? Why not anywhere else?
Because 31 and 32 are separate.
Oh, very good. So now I have a connection. The two numbers that I chose, 31 and 32, are co-prime, and therefore they cannot match unless we are looking at 0 or that number. Is this clear? Yeah? See, the two are co-prime, and therefore HCF is 1, which means that unless it is 31, it will not coincide. Unless it is 0, it will not coincide. Anywhere in between, it does not coincide. So far, okay? Now, if I take one of the units, in the original scale, it is 1 centimeter. What is the length of the division of the second one?
31.
Write it down. Write it down. Because it doesn't end here. A lot more is there. So, go ahead. The beauty is actually recognizing that co-primes can be used powerfully. It is one thing to get something mathematically, but it is another to use it in terms of daily use. Yeah? Now tell me, what is the difference between the original scale and the other, the difference between the two divisions, and how will you calculate? Go ahead. Done?
0.03.
Okay. Now what you do is move the scale a little bit so that this first marking coincides. You understood, no? You have these two strips. First, you matched like this. There is a marking that you have made on the two scales. Now move in such a way that the two markings of the first one coincide. Done? The question I have is, how much movement did you make from the first one to the second one? Is the question clear? So first match it completely like this. And now, in order to make sure that the marking of the first and the second ruler match, you move it such that the two markings match. 1 centimeter marking on the first scale and first marking on the second scale. Whatever it is. Done? Are you done with that? How much movement has happened? 1 by 32. So, the question that we have right now is, what have we gained? Supposing 1 by 32 is fine, or if it is 64, 1 by 34, that much precision that we get, correct? The precision now has improved tremendously. Earlier it was only half and half and half. Now suddenly It was 1 by 32, not 1 by 2. Which means that what we have done is using co-prime, it was possible for us to get measurement better. What is one thing about humans? Let's say you are sitting in a bench. What would be an improvement you want?
Add cushion.
Add cushion. Let's say you have cushion. What improvement would you want? If I keep on asking this question, you will have an answer. And therefore humans are greedy. Correct? Greed is good, right? As long as inventor is concerned, because inventor can invent something, right? So what happened? I'm just going to skip all this. What happened is we got vernier scale. Supposing I wanted to measure the breadth of this entire thing, I would have had to have a vernier scale of that long or break it into many, correct? But this vernier scale also had some limitation, which was 1 by 32. If I want to have more number of divisions and be able to fold, let's say 6 folds or 7 folds, what would I do? Larger size, correct? Larger size is what is necessary. If I want to have so many 10 folds, then I would have had to have the length that is very long. But I cannot handle such a long vernier, correct? But I like that accuracy. What will I do?
We can use an inch tape and we'll measure like most of it, and last few centimeters can be measured.
Okay. Yeah. What else? How will I be now satisfied? Because of course, yes, I got good accuracy, 7 folds, 8 folds I could do.
We can take only one portion of the vernier scale and use that alone to measure the
Okay.
The MSR is
Got, you break it into many is one of the solutions. Anything else? The main scale has to be that long. You agree with me, right?
we have the main scale and then we add a small vernier.
Small is okay, but the main scale is long, correct? I don't want long scale because it's difficult for me to handle. 1 meter scale itself is difficult for me to handle, correct? What shall I do? Let's see the inventor in this class. What shall I do? Huh? Measuring tape. No. Okay. Do you want a clue? Do you want a clue? This is very long, no? Handling a long scale like that is tough. I want a solution so that I want this long scale.
You can take some rope and measure with that and measure with
Okay.
Should we use vernier caliper alone?
So could you tell the criteria once more? You want a small measuring device or you want a bigger one?
See, when I have to fold 7 or 8 times, the length of that main scale will be longer. You agree with me? Because when you tried folding the 6th time, it was tough. Correct? Yes or no? Because it was only 32 centimeters. If it were 64 centimeters, then the 6th one was easy for you. If it were 128, then and so on. Right? So if I have 10 folds or 12 folds that I want, the length of the main scale will increase. Agreed? But handling that long scale is tough. Let's see the inventor coming up with an idea. Huh? Wow! Again, repeat what you said. So, in a building, when you're not able to get the stairs done, what do? Spiral, right? So, what happened was the first invention.
That is measuring tape. So we are rolling it.
No, not measuring tape. But to be able to travel along that main scale is possible if I go spirally. And an invention happened which was screw gauge. Next step. And what is the human's tendency? Means I want more accuracy, correct? Yeah? Yeah? Now, how do I do it? Is a question that arose in the minds of the scientists. But before that, let's look at this, no? Because this will give you an idea of what is really happening. This has 100 divisions. What I did on PowerPoint is I cut off one of those divisions, 99, I stretched it because it's easy in PowerPoint to stretch and made it into equal lengths. But the divisions were 99 and 100. Are you with me? That's what I did. Okay. The total length of the ruler is the same, but one has only 99 divisions, the other has 100 divisions. So far, okay? Now what I'm going to do is I'm going to now overlap them and move one edge over the other. Move one edge over the other. Are you able to see? Yeah? All I'm doing is the left hand side of the top ruler is being moved. What do you see? What do you see? What do you see? Not the chocolate, yeah.
Lines are intersecting and then separating.
Intersecting and separating. Huh?
Lines are becoming closer and faster.
Closer and
Only
far.
one line is intersecting at a time.
Yeah.
Is it compression in that section?
Compression. What do you see?
Lines in between them.
A child of 3 years or 4-year-old will immediately tell me, it's difficult for us now. Huh? What is moving?
The shape.
What is huh? Huh? Band. Who said that? Yeah. A band was moving. Let's see it again. Huh? Let's see it again. Yeah. Now, are you able to see the small movement happening on the top? Yeah. And if you look at the small movement on top and the band, what is the difference you see? Very fast, correct? Compared to the movement that is happening, the band is moving fast, and if I am able to find out the speed of that band, I am probably measuring. Are you with me? Beautiful idea. I tried with 500. You want to see? 500. 500. 499. Put them together. Overlap them. And move them. Look at the bands moving very fast. Yeah, are you able to see it? Yeah? Right? Are you convinced there are bands that you can see? Okay, so we're going to go one step further. Now, what is this? Scale. That's what you made, correct? You made the scale. Supposing the marking, let's say 1 and 2, let's say I'm now going to change it to, if it is 1, it is dark. If it is 2, it is dark. In between, it will keep on changing depending on the division. Are you with me now? Right? If I do that, I'll get something like this. So far, okay? Is this clear? Shall I repeat it?
Yes, sir.
The marking at 1 or 2 or 0 will be dark. As I move away from 1 or away from 2, it will become lighter and lighter. That's what I have done there. And now I can put all of them together. Yeah? Done? Now, instead of lines, I'm now going to use smudged one. I'll get something like this. Agreed? Yeah? So far, okay?
So, but there the divisions are not.
Divisions are not clear, but the intensity will give me an idea of the marking. So far, so good? So, I'm now adding all of them. I have now created a smudged ruler. Take out your notebook and I want you to now draw a graph of the ruler from 0 to 6 as per intensity. Go ahead, draw. Go ahead, draw as per intensity. Darkness high means higher value. Darkness low means lower value. Done? What do you get? Don't say sine wave. Wave, correct? Repeated nature is what you are getting. It's a wave. Oh my God. I started with a ruler. I'm now ending up with a wave. Beautiful, no? Right? And 0 and 1 is one wavelength or half wavelength. 1 and 2 is another half wavelength and so on. Right? I can now convert this into something like this. Right? Don't say sine wave because sine is a function that is showing something like a wave. There are many ways by which you can draw a wave. So far, okay? What did we do now? Honey, I shrunk the ruler into a wave. Beautiful. Now I know ruler is equal to wave or wave is equal to ruler. So what, sir? Why are you talking about all this nonsense? Supposing I go back now to those two rulers. What will I get here? Two waves. What's the difference between these two waves? Slightly change. Supposing I superimpose, what will I get?
Interference pattern.
Huh?
Interference pattern.
Okay, if it is sound wave? Beats. Wonderful. Beats or interference pattern. When you move one scale over the other, what will happen? Bands will be there and the speed of the bands will be fast enough that I will be able to measure. Are you with me? You said something.
So won't there be a phase difference in super?
The phase difference is what you are talking about. The two rulers have a very slight phase difference, sin theta and sin theta plus phi, right? And phi is very small. When you do this, you will get a beat. And we also call that as an interference band. Interference band looks like the ones that we have drawn in between, correct? Yeah? Now we have power. What happened was, people started to use wave interference in order to measure. Now the question arises. I had a 32 centimeter ruler. What wavelength should I use to measure accurately? Should it be 1 centimeter wavelength? Should it be 1 millimeter wavelength? Should it be 100 centimeter wavelength?
1 by 30. 1 by 30.
What wavelength should I use?
As small as possible.
As small as possible. Now the question arises. What question would the inventor have asked? How small? One question. What is the other question? What wave has a small one? Can you answer that question? We have sound waves. Then electromagnetic waves. Electromagnetic waves range from where to where? How many of you know radio waves? Okay. Are radio waves long or short? Long. Okay. And now we are looking at very small wavelength waves. Can you give me?
Gamma.
Madam, you only. Tell me a wave that is very, very small in wavelength. something. Somebody said ultraviolet, they said. Is ultraviolet longer or infrared longer? Infrared longer? Confused. Which is longer? Ultraviolet. So from ultra, you go to infra. Infra, ultra. I want smaller than
X-rays.
X-rays, smaller than, etc., etc., etc. Now, boundless number of different kinds of waves are possible for me to use in order to make it accurate. But when I do this, I have to make sure that there is no diffusion. I want to collect this light in such a way that when you go to cinema hall and press this, you are able to shine on the screen. Don't do it, but how did this happen? What do you call that? What is laser?
Light amplified.
Light? Light?
Light amplified source.
Light? What do you call that? Okay. All right. All right. So if you look at it, if I use an appropriate wave, it is possible for me to get good measurement. And if the change is a very little change, it will be possible to capture that. Are you with me? Right? If I have a wavelength of 1 centimeter and the other one is 31 by 32, I'm able to get a very high accuracy. Here I'm talking about a wavelength that is very small. When I say very small, it could be in terms of a few nanometers. A few nanometers and a few nanometers plus small amount. What will happen? I'll be able to now accurately measure at that level, and therefore today, if you come to one of our labs in my department, you will see a nano interferometer. It will measure a length which is at a nano scale. Beautiful, no? Where did we start from? Where did we start from? Now come on, yeah. Where did we start from? Where did we start from? And we started from a mathematician by name Pierre Vernier, right? It was a mathematician who made this difference. Physics takes help from mathematical discoveries in order to do this. Well, one of the longest waves that people wanted to measure was gravitational wave, and they needed a very long length, two dimensions, because we don't know which direction is the wavelength, and therefore two x and y axes were used. How many of you know the name of this? LIGO. How many of you know that it is available as a laboratory in India? LIGO is at Caltech, yeah. They were making it when I was there also. But the question I have is, in India, oh, it's there, is it? Oh, yeah, good. Yeah, go visit it. This is a facility where that longest wave known to us so far is being measured. The difficulty with longest waves is you can always miss them. For example, your ear will miss larger waves. Of course, smaller also it will miss. But larger waves are easy to miss. Yeah? Any questions? Wow, I finished it earlier than Sachit. Any questions? Any questions? No questions, huh? So what's the inspiration from this? Don't know. Pick up your this thing and tell me. L is for? Oh, very good. I is okay. See, look at that. You are able to now make it out. Yeah. Any questions? Where is the inspiration here? Why are there two lines? Basically, if I have to measure a wave whose direction is not known, I may probably use X and Y so that I can infer appropriate direction. Now, tell me where the real change occurred. Number one, when co-primes were used, Vernier did not use it. He proposed the two consecutive numbers, correct? Somebody borrowed it and used it in the subsequent century. That was the first breakthrough. Second breakthrough, when the length can be now shrunk into a spiral. Number two. Number three, the beautiful change that has occurred is wave is a ruler. Alright. The moment they found that wave is a ruler, the breakthrough broke all the limits, and today you can measure the length even of an atom if you know the boundaries properly. Alright. Thank you.